Now we're going to start on section 6.4. I'm not exactly sure what the actual name of this section is because I'm apparently too lazy to look at my book, which is 3 feet away, but let's go ahead and just call it something like doing stuff with matrices. Not really just doing stuff, solving problems with matrices. Alright, so I've alluded to the fact that matrices are actually super important and super useful, so the question is, well, how would we actually solve these aforementioned fabulous problems using matrices? So we're going to talk about that today, and it's going to take us a while to get there, but I hope it'll be a fantastic and exciting ride. Alright, so did you notice that the last time we've been talking about matrices, notice we've only talked about we've only talked about adding, subtracting, and multiplying, right? What about division? How come I didn't tell you how to divide a matrix or a matrix? A matrix. How come I didn't tell you how to divide a matrix? The reason is you can't divide matrices. You just can't do it. You cannot divide matrices. Don't try. So if I have, for example, a problem like 3x plus 6, or not 3x plus 6, say I had 3x equals 6. I could very easily divide both sides by 3 and get x equals 2, right? Not a problem. However, if I had a matrix like A times x equals some other matrix. If I have a matrix times a matrix equals some other matrix, I cannot divide both sides by A. There is no operation for division of matrices, so we have to figure a way around it. Okay? So let's go back to this analog here of how we did it with 3x plus 6, or 3x equals 6. So we said I can divide both sides by 3. Well, let's pretend I'm not allowed to divide anymore. I can only multiply. Can you get to x equals 2 using only multiplication? This is not really a trick question. The answer is yes. I can divide, or I can multiply both sides by 1/3, right? Multiply both sides of the equation by 1/3 and get x equals 2. And you might say, well, that's just cheating because you divided by 3 anyway. Yeah, but semantics is actually important here. 1/3 and 3 are what we call inverses of each other. Okay, so we've talked about inverse functions. 1/3 and 3 are inverses of each other. That means that if we multiply 1/3 times 3, we get 1. Or if we multiply 3 times 1/3, we get 1. So they're inverses of each other. Rather than dividing something, I could multiply it by its inverse. So you've seen this in numbers before. I hope that this seems like a legitimate way to solve a problem, because it is. But that is, from now on, how you're going to have to solve problems with matrices in them, is you can't divide by a matrix, but you can multiply by its inverse. So that's important enough that I'm going to write it out. So I'm going to say you can't divide an equation by a matrix, but you can multiply both sides by its inverse. Okay, so this is pretty crazy stuff, and if your brain's kind of like going, huh, what are you talking about? What's the difference? Hopefully it will become clear as we go along. Now, this is actually going to take a while to get to, and I think I warned you of that as we started. How do you find, what is the inverse of a matrix? How do you find it? because you can't really multiply a matrix times a matrix and get 1, right? Because, you know, if this was something like that, you'd really have a 2 by 2. You wouldn't have just a number. So actually we define a special 1 for matrices. And the 1 is called the identity matrix. So it's not really called 1, it's called the identity matrix. And for example, in this problem up here where I had a 2 by 2, if I wanted to create a 1 for this, what I would do is I would say 1 on the diagonals and 0 every place else. And we call it I for identity. And the identity matrix is different based on the size. So if I had a 3 by 3 times a 3 by 3, which would give me a 3 by 3, my identity matrix has a 1 going down the diagonals, and everything else in the matrix is a 1. Is a 0. Everything else in the matrix is a 0. So we actually have very specific identity matrices for every size of a matrix. And we're only going to worry about square matrices, ones that are, you know, the same size on both columns and rows. So your identity matrix is going to be a matrix that has 1s going down the diagonal. So how this relates to inverses is if this times, say this one, times this one is the identity, then that means these two matrices here are inverses of each other. So I can say this pair is an inverse. So like 1 and a third, so that's a pair. This is a pair of inverses, so is this, and so with this. If I multiply two matrices together and get the identity matrix, that means that they're inverses of each other. So I'm going to write that out. If I multiply two matrices together, and I get the identity matrix, this is a lot of theory, I understand. And this is for any size identity matrix. Then my two matrices were inverses of each other. Okay, so if I multiply two matrices together and I get the identity matrix of any size, then my two matrices were inverses of each other. And the way that we talk about it in notation is we say, well, if my matrix is A times its inverse, so like your inverse function notation, it's the same thing for matrices. A times the inverse is the identity, and A inverse times the matrix is an identity. Okay? So if I multiply two matrices together, if I get the identity matrix, if I do them both ways, in either order, so I guess I should go ahead and put that together. If I multiply two matrices together in any order, and I get the identity matrix of any size, whatever size it needs to be, then my two matrices are inverses of each other. Okay? So, just like, in summary, summary, not summary as in we're done for the day, just summary. So a number times its inverse is 1. A matrix times its inverse is the identity. Okay? So this isn't crazy stuff. This isn't like, wow, I've never seen this before in my life. Maybe you've never seen it before with matrices, but you've definitely seen it before with other kinds of things. So for the moment, I'm not going to really worry about how you find matrices by hand. We're going to do that kind of stuff on the calculator for the most part, although I will show you a trick for small matrices. But you're going to have some problems where you go and you say, okay, let's verify that these are inverses of each other. And that's where we're going to get started on the next lecture.